Hello dear student, I welcome all of you to the discussions on the quick solutions of the All India Cast Test Series Medical 2020. This is for the TYM batch and this was conducted on 21st February 2021. Now let us proceed to the first question of this test. The first question says, a submarine is floating at a depth of 1000 meters in an ocean. The force on window having dimensions 20 cm cross 20 cm of the submarine is, the density of seawater and the atmospheric pressure is given. Now the student, the pressure at the bottom has a gauge value of rho gh. Now this will be equal to 1.03 into 10 raised to power 3 into 10 into 1000. Now the student, the force will be equal to this pressure multiplied by area. Now the pressure is 1.03 into 10 raised to power 3 into 10 into 1000 into 0.04. So this will be equal to 4.12 into 10 raised to power 5 Newton. Therefore for this question the correct answer should be option number 2. Now let us move to the second question. In the second one, two syringes of different cross sections filled with water are connected with tightly fitted rubber tube filled with water. The diameter of small piston is 2 cm and that of larger is 6 cm. What will be the force exerted on the larger piston when the force of 10 Newton is applied on the smaller piston? The student, for this we will use the concept of the Pascal's law. As per the Pascal's law, the excess pressure on both the sides will be equal. That is F1 by A1 is equal to F2 by A2. This means that F2 can be written as A2 by A1 into F1. Now all we need to do is substitute the values. A2 will be pi into 3 into 10 raised to power minus 2 square. A1 will be pi into 1 into 10 raised to minus 2 square. And F1 will be 10, which on solving turns out to be equal to 90 Newton, meaning that for this question option 3 is the correct answer. Now moving on to the question 3. The student, question 3 says the flow of blood in a larger artery of an anesthetized dog is diverted through venturi meter. The wider part of the meter has cross-sectional area of 8 mm square and the narrow part has an area of 4 mm square. The pressure drop in the artery is 24 Pascal. We have to find out the speed of blood in the artery. Now for this let us use the Bernoulli's theorem, but beforehand let us write down the ratio of the areas. This will be 8 by 4, that is 2. Now as per the Bernoulli's theorem, P1 plus half rho V1 square will be equal to P2 plus half rho V2 square. Also we must know that AV1 is equal to AV2. Now the student, if we substitute these values, we will be getting is P1 minus P2 is equal to half rho V1 square multiplied by capital A by small a whole square minus 1. So V1 will be simply under root of 2 delta P, which is P1 minus P2 divided by rho capital A by small a square minus 1. On putting the given values, the correct answer turns out to be 0.123 meter per second, and hence for this question the correct answer is option 1. Now moving on to the question number 4. Dear student, let us solve the question number 4. Question 4 says two bodies of volume V and 2V are equalized on a balance. The larger body is then immersed in oil of density 0.9 gram per centimeter cube. What must be the density of liquid in which the smaller body is simultaneously immersed so as not to disturb the equilibrium balance? The student, the two bodies will remain balanced if their loss of weight are equal, which means that 2V into 0.9 g will be equal to V into sigma g. This means that sigma will be equal to 1.80 gram per centimeter cube. And hence for this question the correct answer is option 1. Now let us move to the question number 5. Question 5 says an application of Bernoulli's equation for fluid flow is found in. So 4 options are given to us. The correct answer for this is the Magnus effect. Magnus effect is the application of Bernoulli's theorem in which the pressure difference is created in air of spinning ball. If there is a spinning ball, then due to the difference in the velocities of air on both sides, the pressure difference is created, and this pressure difference leads to the deviation of the path of the ball from the rectilinear path, and hence the correct answer for this question is option 3. Now let us move to the question number 6.